So we're looking at this first practice question, and this one is a pretty conceptual question. So we're saying, okay, in time t, an amount of heat Q flows through the solid door of area A and thickness D represented below. The temperature on each side of the door are T2 and T1 respectively. Which of the following changes would be certain to decrease Q? So we want to decrease the amount of heat that we have coming through here. So take a quick second, pause this video, give this a go, and then we'll talk about it after you try it out. But yeah, so try it out, have an answer, pause it, and then we'll come back to it. Okay, so hopefully you came back to it. So this is really, like I said, kind of conceptual. Yes, we're using our equation, but we're just going to kind of use it in a conceptual way. So we want to see how all of these variables are related without doing any math. So you're saying, okay, what we want to do is decrease this Q. So we're thinking about what variables we can change over here to make the variable on the left side go down. So pretty much what we want to see is which ones are directly related. We'll check those first. So increasing A only. It looks like Q and A are directly related to each other. So if we increase the area, if A goes up, then Q will go up too. So that's not good. Decreasing D only. So D is what they're kind of calling the thickness here. So if we decrease D, if it's very thin, we'll have less particles to work our way through for both these faces, and it'll actually be easier to transfer that heat. So this one is out also. We're kind of saying, hey, this is, maybe I can cover it up with a white one. Oops. Calling this D. Alright, so if D goes down, then we're going to have an increase in Q because those are inversely related to each other. Increasing D and T2 minus T1 only. So if we increase D, these are inversely related to each other. So increasing D will cause a decrease in Q, so that's good. And then increasing T1 minus T2 or T2 minus T1, that will increase this change in temperature term. They'll be closer to each other, so it'll be harder. If we increase the difference, then heat will flow more. So those are directly related to each other. So this one is not good. Decreasing A and T2 minus T1 only. So if we look at this one, if we decrease A, these are directly related to each other, so that's good. And if we decrease this temperature difference, those are also directly related to each other. So this one looks good. Increase dA and T2 minus T1, that's not good. We already said increasing these, it will not do it. So it looks like we have D for our answer. Conceptually, if we're checking, if we decrease A, we'll have less particles to collide on each side. So that's good. We'll have like only a little bit of particles, rather a lot, so we won't be able to transfer heat as quickly. And then if we change the temperature difference, I already said if they're really close to each other, when the temperature difference is 0, that's when we have no heat flow. No net heat flow. So if this is closer to 0 as delta T approaches 0, then our heat flow rate is going to approach 0 as well. Okay,